So in the last video, we went ahead and we configured the point-to-point links and what those were and how to do that across the core area of the network. Today now we're going to try to get full connectivity across the network by adding in some routing protocols like RIPv2 and OSPF. So let's get started. So our scenario for this says that RIPv2 will be used to provide routing for the routers in the internal network and static routing for the external server. So the external servers here, I'm not building the internet just yet, or the mock internet, and I'm going to change this up a little bit. So I'm going to use RIP internally between the distribution layer. Okay, so these two distribution switches, I'm going to use RIPv2 to advertise the internal network. And I'm going to use OSPF for the core side of things. And then what I'm going to do is I'm going to use OSPF to redistribute the RIP subnets. So let's get started. So the first thing we're going to do is we're going to use the main campus, and this is the main campus switch. And we're going to give that a second to load up. Plus coffee. Okay, so first let's take a look at our routing table. And we'll look at what we're connected to. Okay, so we can see that all of these are access layer switches, and this is our, including the HR, and this is our campus core, and we have their interfaces that we're connected to. We are going to use RIP to advertise all of these local networks. So we're going to enter configuration. We're going to go in configuration mode, and we're going to do router RIP. Okay, by default, when you enable RIP, it'll do RIP version 1. We don't want RIP version 1, and it's really not used anymore because RIP v1 only does classful. Will only advertise classful networks. So class A, B, and C, the whole thing. It doesn't do VLSM, variable subnet length masking. It doesn't do any type of CIDR notation. None of that. It just, here's what you get. So we're going to enable version 2. RIPv2 will now allow you to use CIDR notation. It will advertise. It will allow you to do VLSM. And there's some different security features, like when it used to do authentication on RIPv1, it was set in plain text. So there's behind the scenes, there are different authentication methods. We're not going to go into that on this one. We're just going to simply use it to advertise the local networks. Okay. Now, if you ever forget what a command does or how to do something, you can always hit the question mark, and it'll give you all the options. One of the first things I'm going to do is I'm going to do no auto summary. The reason I'm going to do no auto summary is because I want the network to be advertised. I don't want to summarize the network into its smallest, the smallest network that encompasses all the underlying subnets. I don't want to do that. I want to explicitly define the networks that I want it to advertise. If you allow it to do auto summarization by default, it will actually advertise, depending on how you look at it, the smallest network that encompasses everything or it would be the largest network for that particular group of subnets. So we'll disable auto summary, and then I'm going to do show IP route because I want to advertise all of my locally connected networks. And then you're simply going to do network 192.168.1.0, and we're going to do 2.0, 3.0, and 4.0. And if you go back and look at the topology, if you've created it the same way that I did, you'll see that those are all the networks in building A. And now we're going to go into building B, which should be 11.0, right? And if I look at my routing table, 11.0, and then 12.0, and that should take care of building B. And then building C should be 21.0 and 22.0. I'm also going to, because it's directly connected, I'm also going to advertise the point-to-point link. 16.1.0. Yes. Before I save it, let's go ahead and we're going to double check our routing table, which it won't display here because these are directly connected, but if we do a show run and let that build. Here's our RIP configuration. We're using version 2, no auto summary, and then these are all the networks are advertised. I could just hit Q and stop it, but there we go. So there's RIP. So we're going to go back into our topology, and I don't want to move on to OSPF just yet, so let's go into the secondary distribution switch, and we'll let that load up. And we'll do the same thing. We'll look at our routing table, and here are directly connected or locally connected networks. So we are going to go into configuration mode, router RIP, version 2, and then we're going to enter the networks to advertise. So we'll do 16.1.8 network, which is our point-to-point link, our 192.168.31.0 network, which I believe is floor 1, and then we're going to do our 41 network, which is floor 2. And then if we do a show run, and there it is, our version 2, RIP configuration version 2, and then our directly connected networks. We'll save that here. I don't remember if I saved that over here. I didn't, so we'll save that. So great. We now have both routers for each, both distribution switches for each campus advertising their internal routes. And that kind of fulfills part of the scenario here. RIPv2 will be used to provide routing for routers in the internal network. Okay, so did we open it up? I think we did. We did. Okay. Now what we have to do is for the internally facing network, because we want this side of the campus to be able to reach this side of the campus. And while we did enable RIP advertisement and the routing protocol across the switches, there's still no way really for it to traverse the actual core network for one side to be able to reach the other. The routers, and which one did I open? Well, I'm going to start with the main campus. The routers have no idea about the internal networks because RIP is not enabled on them. So it's not accepting the advertisements. So what I need to do is I need to go ahead and I need to configure the router, the core router, for RIP. I still want it for version 2, and I want no auto summary. If I look at the routing table, I'm going to give it a second. Huh. Not getting anything. Well, while I have RIP enabled, I don't actually have a network that receives the advertisements. So what I'm going to do is I'm going to take it's already up here. I'm going to take the point-to-point link that faces inside the network, and I'm going to advertise that network through RIP. So that is going to be the 172.16.1.0 network. So I'm going to do router RIP network 172.16.1.0. Give it a second. Can't talk today. And now the router is receiving the advertisements and updating its routing table with the internal networks. So there you see building A, building B, and building C network IP addresses. Perfect. So now, let's go ahead and save that configuration. Well, let's do a show run, just to see how it looks like in the config. And there you go, router RIP version 2. It's the, so remember what I was saying earlier about advertising AutoSum, or advertising the largest network. Technically, this is a Class B network that I've subnetted out into /30s for the point-to-point links. And it still summarized that. I don't know if that's a bug or maybe if I did it out of order, but that's what auto summary looks like. Because the 172.16 as a Class B or /16 is the largest subnet, the largest network that would allow the subnet that I've included. If the way I described that makes sense. going to do is we're going to do a clear IP route. Oh. I'm trying to remember how to do this. Do I have any static routes? I don't. So we're going to clear them all. Okay. And then we're going to wait. And we're going to do the same thing. Do a clear IP route. We're going to clear them all. And then now all we have are the routes that it learned through RIP internally. Same thing here. These are all the RIP routes that it learned internally, but notice how they're no longer going across the core network. So this router has not learned any of the networks on the other side, and vice versa. They only know about their own internal networks via RIP. Now we're going to change that using OSPF. I didn't want it to go through RIP. So if you don't want RIP advertisements being sent out, you're going to need to use the passive interface command, because that will receive the advertisements, but it won't distribute them. So, great. Now we've fulfilled the scenario requirements. We have the internal routes being distributed through RIP up to the core. Same thing on this side, up to the core. However, if we want to reach one side to the other, there's no way of doing that because one side doesn't know about the routes. So what we're going to do is first, we need to tell this side where to send the data to. And the first thing we have to do is set a default gateway or default route. So if a packet comes from, let's say, an admin PC to the distribution switch at layer 3, it'll look at its routing table and see, I don't have that entry in my table. I don't know where to send it. So what we're going to do is we're going to tell it to send anything it doesn't know about out through a default route. And how we're going to do that? We are going to use the next hop interface, which is the main campus core, the IP address of the gig 00 on the core router as its default route. So we'll look here. So this here, the next hop, right? The next hop, G00 interface is going to be 172.16.1.1. So we're going to do IP route 0.0.0.0 with a subnet mask of 0.0.0.0, and we're going to use the next hop address as its default route, or gateway of last resort. So now if you look at your routing table, anything that doesn't show up here, that it doesn't see in its routing table, that doesn't have a path for, it's going to send out of this interface. The reason being is I'm going to send it up the chain to the next router. Hopefully the next router knows what to do with it. And we're going to do the same thing on this side. So we're going to go to the campus core. And let's look at what the next hop is. So the next hop is going to be, oh, sorry, I'm in the core. Secondary distribution switch. gateway of last resort. So we are going to set the gateway of last resort to be the IP address of the next hop's interface. So look at CDP neighbor, and we see, okay, the secondary campus core is going to interface 0, 0. So that address should be the 172.16.1.9. So we'll do IP route 172.16.1.9. Look again at the routing table, and there we see anything that doesn't pop up in its table is going to go out of the interface to the next hop. Perfect. And we'll save that. And we'll not do that. I gotta wait for that to close. But in any event, so great. Now we know anything from here will get sent up to the core, and anything from here will get sent up to this core. But how do we get them to cross the network? Because there is no this campus core here has no routes for this side, and this campus core here has no routes for this side. So what do? This is where I'll set up OSPF. And the reason why I want to use OSPF is because, quite honestly, I don't. RIP has limitations up to 16 hops. It also has a slow convergence time by essentially manipulating its table by taking the advertisements, going through its table, updating its database, compared to OSPF. OSPF has a faster convergence time of getting that done. And OSPF also uses a different algorithm. It's a different type of protocol to determine which is the best pathway to take to a particular network. Now, a small network like this, there's not much calculation that goes on, but when you start going into enterprise networks, where you have multiple pathways to take to different networks, that's going to be important, and that's going to be important for network efficiency. So for the sake of practice, we're going to enable OSPF, and we're going to make it a single-homed, one area OSPF. We're not going to do multi-homed. So we'll start with the campus core. So we're going to do configure router OSPF 1. We have to give it a process ID. And now what we can do is we can start advertising our networks. So we'll do show IP route, but I'm only going to advertise the connected networks. 172.16.0, and you do have, and with this you do have to put the wildcard mask of the network. So instead of being 255.255.255.252, it won't let you do it because you have to use a wildcard mask, not the subnet mask. So instead, we're going to do a 0.0.0, and 0 is the same as a 255. That means this octet, this octet, this octet. .3. Ooh, I messed up somewhere. I did. I didn't put the full address. 172.16.1.0. 1, 2, 3, 3. I'm also going to put it in area 0. Area 0 is required. It's considered the backbone area. So you need to have an area 0 at least when you're configuring OSPF. And then we're going to advertise the other connected network, which is 172.16.1.12. Same wildcard mask, because it's a CIDR 30, area 0. We're going to end it. We're going to do a show run. And there you see, we have, stupid fly, we see the network configured for area 0. Perfect. Now we're going to do the same thing on the campus core because we have to set up an adjacency. So we're going to do a show IP route just so that we can get our connected networks. And if you want to be, and if you just want to see the connected networks, we can do show IP route C. And notice how it doesn't give me the RIP routes in this table. Conf T, router OSPF. We're going to give it the same process ID of 1. And now we're going to advertise our connected networks. 172.8.1.8. Same thing as /30. Area 0. And then we're going to do the other one, 16.1.12. 3 area 0. And notice that now we have OSPF running on the other interface, on the other side of the network. It's established an adjacency. So now it goes from loading to full because that adjacency has been established and that entry is now in its routing table. So now if you look, this network here is being advertised by OSPF. And that 1.0 network is this network here. We'll save the configuration. We'll save the configuration. So now this campus core now has the ability to reach this side of the link. So I should be able to ping this interface IP address from here. Secondary campus core. So if I do ping 172.16.1.2, I can successfully traverse the network from here to here. Now what about here from the secondary distribution switch? Can I ping from here across to this side? Let's find out. So I go to the secondary distribution switch. I'm going to do the same thing. Ping 172.16.1.2. And I can successfully go from here to here. And I can show you that by doing a trace 16.1.2. And it goes on the 1.net network, the 1.8 network. It goes from here, so you see it's .9, so it hits the next hop interface because that's what we set as our default route or our gateway of last resort. So it sends that packet out to this interface. It goes across the network, hits the next interface, and then is finally received on the interface of the switch. Now, can I ping the SVI? Because it's on the switch, and I can get the switch, right? And I believe it was 1.1. Let's try again. happens if we trace it? So it gets to the next router because the switch doesn't have a pathway, and it goes, oh, I'm just going to toss it up to the router, let the router do what it's got to do. But the router has no idea what to do with it. Well, there's two things I can do. I can do the same process and let the next hop be the gateway of last resort and see how that works. But what I'd like to do is I want to redistribute these RIP interfaces, or these RIP routes. But I don't want to advertise them through RIP. So what I'm going to do is I'm actually going to let OSPF handle it. And the way you do that is you redistribute RIP subnets. And I'm going to do the same thing on the other side. And I'll give it a second. And now I have all the networks from the other side, or I now have pathways to the other side redistributed through OSPF. And if you look at the table here, it's an OSPF route and it's external. So now if I go into the switch and I want to try to do the same thing again, notice it hits the router, next hop, because it's our default gateway. The router sends it across the network and down through the other interface. So now, by redistributing the RIP routes through OSPF, I have an end-to-end connection between the main campus and the secondary campus. There are other ways to do that. The reason why I wanted to do it this way was just to practice, well, one, to fulfill the scenario requirements of internal network being advertised through RIP, but I also wanted to practice or show how to redistribute one protocol within another routing protocol. And then the one final thing that we have to do, or two, we still have 2 steps left, but we have to now set up a DHCP server so that the devices in building A will acquire their IP addresses dynamically. I changed that a little bit because every time I shut down my lab, I have to reset the information for the VPCs. So what I'm going to do is I'm going to set up a DHCP server for each network, so that every time that I do have to power on these devices, they just acquire their IP addresses dynamically, and I don't have to keep setting them. The requirements are just for building A. I'm going to do it across the network because I'm lazy, and we try to make things easier for ourselves. But we'll take care of that in another video.